Bismillahirrahmanirrahim. Assalamu alaikum and welcome to another episode of Space for All, the official podcast of ISNET. I'm your host, Sadaf Sajjad, and today we are diving into the crucial intersection of space-based data and global water challenges. Across the world, communities are grappling with water scarcity, contamination, and management challenges. In this landscape, the United Nations Office for Outer Space Affairs, UNOOSA, is leading a fascinating initiative, the Space for Water project. Joining us is someone at the heart of this very work, Ms. Nina Kippinger, Associate Information Systems Officer at UNOOSA and Manager of the Space for Water project. Nina combines a strong background in software engineering with deep experience in international diplomacy and multi-stakeholder collaboration. Welcome to the show, Nina. It's a pleasure to have you.
Thank you very much for this invitation. I'm excited about today's interview.
Thank you so much, Nina, for accepting this invitation. So could you start by giving our listeners an overview of the Space for Water project, what inspired its creation, and what gap is it aiming to fill?
The Space for Water project by the UN Office for Outer Space Affairs and the Prince Sultan bin Abdulaziz International Prize for Water is an interdisciplinary multi-stakeholder initiative based on three pillars: a conference series to strengthen the links between academia and governmental institutions mainly, a web portal for science communication, and a community of practice that meets regularly and co-designs space-based solutions to address water issues globally. It was initiated based on the cooperation we had ongoing with PSIPW in organizing conferences together since 2008, one of which was very successfully hosted in Islamabad in 2018 with amazing hospitality by Suparco. And there was the wish by PSIPW to create a web portal featuring experts using space technologies for water management. So in 2018, we kicked off the Space for Water portal. And when we started, coming from the perspective of space, looking down at water on Earth from space, it became pretty clear that we're going to look at the whole water cycle. So we decided for an inclusive approach from source to sea and back, so to say, if you consider the atmosphere, precipitation, and all other aspects of water. The interdisciplinarity of the community is a key asset, allowing us to address issues all over the globe in all shapes. Water issues, of course. And this is, of course, challenging, but there's a reason why increasingly many actors start to understand the human links to the water cycle and the need to look at things a bit more in terms of larger scale systems. So we are very happy we've picked this bird's eyes or satellite eye perspective and a more systemic approach to it. What gap is it aiming to fill? I asked myself the question so many times because I didn't want to create something that is already there. That is a waste of valuable resources if you think we have so many challenges to address. We don't have the luxury in times of climate change when solutions are so urgently needed. And at the same time, it's not easy to find gaps and to fill them in a world with so many actors working on water issues at the same time. So we're a small actor, but the niche we picked is definitely one related to knowledge exchange, mutual knowledge creation. That is at the heart of the project. And the inclusivity I mentioned is a key asset. Not only do we work interdisciplinarity with all stakeholder groups, that includes governmental institutions, academia, that includes non-governmental organizations, the private sector, and intergovernmental organizations. But we also include actors at all levels, from the local to the national, regional, and global level. And these links benefit from being strengthened. In the Space for Water community, you can have a head of department of a space agency collaborating with the technical staff of a water agency and a young professional, a PhD student, and possibly a representative of an affected indigenous or local community. And the collaboration is voluntary. It can take some time, and it produces space-based solutions that we publish on the portal with the aim to inspire others in need of a similar solution. So interested parties can reach out and learn more about this suggested approach. We also started developing good practices, and our first good practice will soon be published and will focus on how to choose a data set. The questions you need to ask yourself before picking a space-based data set and running your analysis. And the overall focus, I would say, of the project is to equip water managers, hydrologists, and ecosystem managers with the skills to use space-based technologies and data to empower them to tackle the challenges that they are expert in.
Thank you, Nina, for giving us a very detailed explanation. And it's amazing how this initiative is involving so many various stakeholders, and the inclusive nature of this very project is truly admiring. Moving on to the next question, can you share some real-world examples where the Space for Water project has supported communities or governments in countries facing acute water crisis? It can be drought, flooding, or mismanagement of water resources. What kind of impact did space-based data or collaboration had on the ground?
Having an impact on the ground, starting from a space-based observation, it takes some time. But we have made some progress in that field. We started with the hands-on solutions development, I think, end of 2022. But what we've done so far, where we can see some impact starting to take shape, is together with the Bahrain Space Agency, we developed a solution to identify potential locations for groundwater recharge from space. We're now continuing the collaboration, assessing if GRACE can approve the modeled data based on soil moisture and in situ data. Why are we not using GRACE from the start? Because many of you will know that this mission can give you mass changes, and you can deduce from it the changes in groundwater. But Bahrain is a very small island, and it's surrounded by the sea, by a lot of water. So the fluctuations in groundwater will be so minimal that it will be hard to attribute it to the groundwater changes if you look at the total water mass there. So now we're only going to use GRACE as a validation if we see that the fluctuations are matching with what the other model results in, taking into account the hand model and surface soil moisture, excuse me. It's a very important project for the country, as the Bahrain Space Agency has assured us. And it's going to be used for decision making. However, the next step is in situ data verification and this GRACE-based verification. Following heavy floods in Kenya last year, we've also published an article on the assessment of flood risk using space technology in Matuga State, that's Kenya's coastal area. And we've received soil and watershed data from the Directorate of Resource Surveys and Remote Sensing in Nairobi, Kenya, and integrated these with space-based data to develop flood hazard maps. And the representative from the institution providing the data ensured us that this will help inform decision-making for future flood events. This article was written by David Canito. He's a Space for Water young professional. Another group within the Space for Water community developed a tool to identify optimum sites for runoff of rainwater that can be applied to address water challenges faced by Ghana, Madagascar, and Kenya. Another solution for identifying optimum sites for rainwater harvesting for drinking water purposes is also currently being developed. So we haven't had like the beneficiary having better water yet based on these solutions, but we see that the governmental institutions we're working with are telling us that this will inform decision making in a few of these cases, and we are quite far with the cases that I mentioned. In the case for this runoff rainwater harvesting, they developed the Google Earth Engine tool. We will soon put that on the portal. It's already developed, and you can use that to look at any site globally wherever there's availability of the data sets. They picked global ones, but they don't perform the same way everywhere. But in test locations, we can see that the tool gives you optimum sites that you can install a pool or a tank and start collecting water. At the moment, we host 13 groups that meet once per month on different thematic focus areas, and they're developing 19 solutions from groundwater management to water quality monitoring, land use, land cover changes, and reservoir protection, for instance, the latter being developed for Venezuela, where they want to decide which basins have been affected by heavy land cover land use changes, by urbanization, by changing forests into agriculture, and which impact does that have on the water bodies. So they are able to decide which reservoirs do they need to protect, and the basins that surround them, so that they can ensure drinking water for the population is granted. This will be a very impactful project, but we are just developing it now. There's also irrigation and crop modeling in the Indus Basin, urban stormwater management, and transboundary water management in the Himalayan region. And we'll have a particular focus on floods, glacial lake outburst floods, and landslide in this region. That's where we stand so far.
So indeed, a lot of practical applications that you, case studies that you shared with us. Moving on, how accessible is this data to water practitioners in low and middle income countries? Are there efforts under Space for Water to democratize access?
In terms of democratizing access, there's several angles to answer this question, I think. It could be from the perspective of open access to data, user-friendly data formats and inclusivity, and the capacity to use the data. In terms of open access to data, there's a vast amount of data of different types out there, and many are in the open domain, such as Landsat or Sentinel data. So they are already accessible. Mm-hmm. Only if a very high resolution is needed, under 10 meters, proprietary data come into play. And what I see is needed more is the capacity on how to choose the appropriate data and how to use it, rather than the actual need for higher resolutions. That is, in many cases. Of course, there's cases in which you need high resolution data. One example is assessing water quality of a very small stream. If it's very narrow, the resolution of 10 meters will not give you a lot of detail. Now, in terms of inclusivity, in the case of disasters, for instance, UNOOSA already contributes to providing data for actors in need. That happens in the context of the Sendai framework, for which we can activate the charter. And in case a natural disaster is happening and the charter is activated by any of the members, the proprietary data is freed up for use to react to the emergency. And that is really good. And it's a great example of how access to data can be democratized, opened up from the private sector to address the needs related to a natural disaster. This is an example that is not directly related to Space for Water, because it falls under the UN SPIDER project, the Space-Based Information for Disaster Management and Emergency Response project of USA. But of course, it's water-related disasters. And today we feel the effects of natural disasters. By 90%, they are related to water. So a lot of the disasters we experience are water-related, and then the users of the Space for Water project indirectly also benefit from that. UNOOSA can also, on a one-on-one basis, sometimes use their partnerships with the space agencies and data providers to grant access to satellite data. But since we're small, our resources are also a bit limited. We did that for the first time during the 5th Space for Water stakeholder meeting, and we see that this leads to more impact, because if we give them the access to data they need, they can make a difference also if they follow through. In terms of capacity building, as I mentioned, we organize conferences during which we also host trainings. And we work in interdisciplinary teams in the context of the Space for Water community, where members mutually learn from each other's experience during the hands-on exercises. So if you're in a group and you're working with someone on a topic that you're interested in, but you've not had so much experience yet, and you see how they're using data sources and accessing the data, you may also develop your own capacities or strengthen them in terms of dealing with data access. I hope that answered your question.
Yes, it pretty much answered my question. And I also hope that in future ISNET can collaborate with UNOOSA and the platforms that you shared, we can collaborate together and work on the Space for Water project together. So the next question is, what are some upcoming priorities or expansions planned for the Space for Water platform? If you can share with us.
For the portal itself, what we're currently working on is translating a lot of the articles into the 6 official UN languages. We have so far translated a number of articles to French, Spanish, and Russian. We've not started yet with the Arabic translations, but if any one of the listeners from the ISNET podcast is interested in supporting this initiative, please reach out. We can collaborate to make this body of knowledge accessible in Arabic-speaking countries. I think that would be an asset and a value addition. We've been expanding the project over the last couple of years significantly. So today we have over 180 community members from across the globe, and we work in 13 thematic groups that I mentioned that meet once per month to design space-based solutions. And this is at the moment our focus, because I find that with these solutions being developed, we can really have an impact on the ground. It is nice that we meet and we exchange and learn from each other, but it's even better if while we learn from each other, we also develop things that make a difference in terms of the sustainable water management on Earth. So I focus a lot of the energy on this part, on this hands-on community interaction. New areas that we recently started that are not in the future, but we started in the last year hosting quarterly webinars, and the next edition is hosted in September, featuring work by the Bahrain Space Agency. We also have an edition in December focusing on agriculture and crop management by the Punjab University. University of the Punjab, I'm sorry. At the moment, we don't have new features planned for the portal, but based on our regular assessment of user needs, we also we are flexible in integrating those. So I have a certain time associated to developing the portal further, and then if there's a need expressed and if we think this feature makes sense to add quality to the portal, we'll integrate it. So suggestions are welcome. We currently evaluate the project, and if we find there new features that would make sense, we will implement. What I would love to integrate is actually a collaborative mapping platform for the solutions. But to do that, we would need more funds to grant all the community members, which are many now, with access and login details to a technical platform for collaborative mapping. I think this would allow not only to document these solutions, but to make them accessible in native maps that others can learn from.
Thank you, Nina. You shared some pretty exciting plans for the Space for Water platform. Now, you have worked at the intersection of technology, diplomacy, and sustainability for quite some time. So from your vantage point today, what's one space-based technology or innovation that excites you the most right now in terms of its potential to address water-related challenges?
I'm really excited to see what potential is hidden in the surface water ocean topography mission and its future applications. I've recently seen a presentation at the Living Planet Symposium that took place end of June in Vienna about the potential to use it to detect water under tree cover. I've also read a paper once on the potential of using synthetic aperture radar to do that. Those are still in experimental stages, I think, but it would make a huge difference in the assessment of floods, monitoring mangrove ecosystems, the interaction of watersheds and forests and wetlands that all have really important ecosystem functions. And something that doesn't exist and that I hope will improve in the future is the resolution of the GRACE mission. GRACE data are quite coarse resolution, and we need to do better in understanding the hidden resource of groundwater, and doing so from space would be making a key difference, because a lot of efforts are involved, of course, in monitoring that with in situ data. And we're depleting the resource at alarming rates. So it would be amazing if there would be developments.
We look forward to this future expectations that you have. And to conclude today's podcast, how can individuals or institutions, especially from the Global South and the OIC countries, get involved in the initiatives? If you can share with the audience some links. You mentioned about the portal, but briefly to conclude, summarize the audience on how they can get involved.
So individuals can join as a Space for Water professional, a young professional, or a representative of an indigenous community. Those are the individuals that can join our community. They, based on an assessment of their background, some quality check, they are featured with a profile page and a written interview. And once you've joined, you are allowed to participate in our stakeholder meetings and the exchange that is going on. Stakeholders, that means organizations of all the different stakeholder groups, can join as organizations can join as stakeholders, and they also will have their profile page. And all community members are encouraged to share information on how they are using space-based technology and data to address water issues. And so it's all about sharing information, learning from each other. But of course, you can also sign up for our newsletter. You find that at the bottom of the landing page of the Space for Water portal. And then you will be informed about upcoming events. You can participate in the conferences we organize, either as a speaker, as a presenter of your academic work, or operational work, or as a listener if you come self-funded or you live in one of the regions where we currently host a conference. The next conference is planned to take place in Uzbekistan in Central Asia. And you can also reach out. You can get involved with the Space for Water community by sending an email to oosa@un.org, OOSA@un.org, or you visit our website, www.spaceforwater.org. We'll put the links in the description, as I heard already.
Thank you, Nina. And I think it's a pretty simple and straightforward process to get involved in this portal, isn't it?
Yeah, basically, at the beginning, there is some formalities. So we know that you really want to become a member. You fill in a form in which we learn about your background. And that's also the basis for your profile page on Space for Water. So for individuals, there would be a biography telling us what's your thematic focus areas, in which regions do you focus your work on, and some contact details so we could reach out, including also your social media channels if you post professional content there. That's for individuals. For stakeholders, we ask a few more questions, not so many. That's the bureaucratic burden at the beginning, but then we'll be in touch via email, and that should be pretty easy.
Thank you so much, Nina. And that brings us to the end of today's episode. A heartfelt thank you to our guest, Ms. Nina Kippinger, for offering such rich insights into the Space for Water project and the power of space-based data in addressing one of the world's most pressing issues, that is water. It is clear that initiatives like Space for Water are not only advancing science and technology, but are also building bridges between countries, communities, and disciplines to create real impact on the ground. If today's conversation sparked your interest, we encourage you to explore more about Space for Water. Ms. Nina will share the link with us and we will put it in the caption. So hopefully you all can get involved more. Until next time, Allah Hafiz and take care. Thank you so much.
Thank you very much for this invitation again. And I would also like to extend my gratitude for ISNET, who has supported Space for Water conferences in the past by funding a few members from member states of ISNET. And I think it's always great if we manage to get more people access to these learning opportunities. Thanks a lot for that.
Thank you.